7.5, and we are going to talk about our formulas for surface area and volume of cones. So we're going to do what we've done before, and figure out what's important about cones, what makes the shape a cone. So let's talk about what we know about cones, what's going to be important. So what kind of shape is a cone going to be? What do we think? Has something to do with a circle. Okay. So I'm going to write, Jay says our base is a circle. The base of our shape is one of the important things we've been talking about. Let's go a little more basic. Is a cone going to be a flat shape, a three-dimensional shape, 3D? So our cone is going to be three-dimensional. I'm going to call it a solid, or let's call it a figure. Three-dimensional figure with a base that's a circle. And our side is kind of like the side of a cylinder. Our side is just a curved surface. So the side of our cone is a curved surface. We could talk about what shape it is. We'll talk about it when we talk about the net. But for now, we'll just say it's a curved surface. So let's get a picture of a cone and label all our parts like we did with our other shapes. All right, so here's our cone. So let's label our parts. This is going to be our base, the circle. Go ahead. So our circle is our base. I'm going to call this H. This segment is our altitude, which is where we find our height. So that's how we find our height. I'm going to put an R here. And this is our radius. That's the radius of the base. And I'm going to draw in a red segment here, and I'll make it a little thicker. Along the side. And this is our slant height. And right up here at the top is the vertex. So these are parts of our cone. So the way that we labeled this, what shape does this remind you of? A shape that we've worked with before? Pyramid. It's kind of like a pyramid. We have this altitude in the middle. We have a slant height. We have a vertex. We have a base. So cones are a lot like pyramids, and the formulas are going to be like pyramids. Now, like we talked about with pyramids, I want to point this triangle out. So let me draw that separately. I'm going to come over here, and we'll draw a triangle. So with a cone, we always have this right triangle with the height, the radius, and the slant height. I'm going to call this L for our slant height. So just like we do with pyramids, we have this right triangle between the height, the radius of the circle, and the slant height. So we can use this right triangle here to figure out one of these other parts using the Pythagorean theorem. So when you're working on problems with cones, you want to remember that there's this right triangle in the cone, because that comes up in a lot of the kinds of problems that you have to solve, just like it does with pyramids. All right, so a couple more things and then we'll get to our formulas. Right cone. A right cone means the altitude hits the center of the base. So I'm going to say it meets the base at the center. So this cone that we have, that we drew here, this is a right cone because our altitude comes right into the center of the base. An oblique cone is just slanted. So let's draw a small picture of an oblique cone. So an oblique cone would look like if this was my base, and this is the vertex. Oops, we'll make the vertex there. This is my oblique cone. So it's just slanted. And like we did with triangles, our altitude is outside the cone. So oblique just means slanted, and on an oblique cone, our altitude, we find our height outside the cone. All right, any questions before we go to our formulas? All right. Our surface area formula. And our formula, surface area formula, is for a right cone. So the surface area of a right cone and for our surface area, we need two things. L is the slant height. And R is the radius of the base. Our surface area is pi RL plus pi r squared. And our units are squared. And we talked just a second ago about how cones are kind of like pyramids. This piece is the area of the side. And this piece is the area of the base. So just like a pyramid, we find our surface area by adding the surface area of the side to the surface area of the base, to the area of the side to the area of the base. And we'll talk about the shapes here in just a second. We'll draw a net for our cone. Questions? All right, let's take a look at what our net for a cone is going to look like. Now I will draw it up here in just a second, but I made one. I made a cone. So a cone, what we do is we start with a circle. So I have a circle here that I drew out on a piece of paper, and we cut a piece of the circle out right to the center. So we take a part of the circle out, and then we're going to fold this up right along that line. And that makes our cone. So the slant height of our cone turns out to be the radius of the circle that I used to make the cone. When I cut that out, the slant height, the radius of this circle is right here. And when I fold it up, that's the slant height of my cone. So the slant height is the radius of the circle that we used to make the cone. And the circumference of the circle that makes up the base, or the part of the circle that makes up the base, the circumference there is the circumference of the circle that makes up the base of my cone. So we have the slant height is the radius of the circle that I cut a piece out of, and the circumference of the base is the part of the circle that I cut out of that's left. So, what's that? No. So let's draw a net. I'm going to draw the circle in, draw a dotted line for the circle that we cut the base, or the side out of. So here's our circle. And then to make our cone, I'm going to do this in red. To make our cone, we cut a piece out of that. So like so, and like so. And then around the edge of that is the part that we're interested in. So that's the part that we're going to fold up to make our cone. And then the base is this circle, like so. So our net for our cone is going to look like the red part here. This would be the radius of the base, is the radius of this circle. And this is our slant height. When we fold it up, that makes the side of the cone. So that's what our net is going to look like for our cone. All right, let's talk about the volume formula. So our surface area formula, one more thing about the surface area formula before we go on. The side of our cone is this piece that we cut out of the circle. It's kind of like a curved triangle. And the sides of pyramids are triangles. So this is, again, showing how this is kind of like a pyramid. Our side is a triangle, and our base is a circle. On a pyramid, our side is a regular triangle, and the base is a polygon. So they're really closely related. All right, let's go to our volume formula. So it's going to be the volume of any pyramid, or I'm sorry, any cone. So our volume. For our volume, we need two things. R is the radius of the base. And H is our height. Our volume is going to be, now let's think about it for a second before we write it down. If we decided that our cones are kind of like pyramids, and we talked before about how cylinders are kind of like prisms, and we related the volume of our pyramid to the volume of our, to the volume of our prism. Let's think about how the volume of a cone is going to relate to the volume of a cylinder. 1/3 is exactly right. So our volume is going to be 1/3 pi r squared times h units cubed. So it's 1/3 the volume of the cylinder. Give me just a sec. All right, so our volume is 1/3 pi r squared h, and I can rewrite this. I can say, just like we did for pyramids, this is 1/3 the area of the base times the height. So this is exactly the same formula that we use for pyramids. Just for cones, our base is a circle, so the area of the base is pi r squared, and we have our height.
So is it still just like 1/3 base times height?
1/3. So we could write it as, if we use capital B for our base area, we could say that's 1/3 B times H, where B is our base area. Yes?
Couldn't you also do the Pythagorean theorem and then just multiply that by the diameter?
Do the Pythagorean theorem.
Like on the right triangle, and then just
The problem is that so you're talking about this, to find around the bottom. Is that what you're thinking?
yeah.
This is only part of the circle, so the side is only part of the circle. So that's why that, if I'm understanding what you're asking, that's why that wouldn't work, because that's only part of that circle. Okay? All right, any questions on our formula? All right, let's do a couple of calculations.
Yeah, calculate.
So we'll do a few examples and then we'll be done.
Do we have homework?
We do have homework. So we have a, listen up guys. We have a right cone. All right, come on guys, let's stop talking please. We have a right cone. Our radius is 6 centimeters. Our slant height is 10 meters, or 10 centimeters, sorry. And we want the surface area. So our formula, we're going to use our formula. S equals pi r L plus pi r squared. And we're going to plug in what we have. So we have pi times 6 times 10 plus pi times 6 squared. For this first part, I get 60 pi. 6 squared is 36, so I get 36 pi. So my exact answer is going to be 96 pi centimeters cubed. Oh, sorry, squared. We're talking about surface area.
So we can leave it in terms of pi.
So if our question asked for the exact answer, this would be our exact answer. If we wanted a decimal, I would plug that into my calculator and I'd find out that that's about 301.59 meters squared. Centimeters squared, sorry. So this is our exact answer. This would be our approximate answer. Now, like we did on our worksheet with cylinders, if the problem gives you the surface area and gives you the slant height and you want to find the radius, you have to plug in what you know into your formula and then solve for the part that you don't know. So we could know the surface area and the slant height and find the radius. We can know the surface area and radius and find the slant height. Just plug in what we know, solve for what we don't know. Questions on that one? All right, let's look at a volume calculation. So we have a cone with a radius of 15 feet. And our height is 20 feet. And we want to know the volume. So our volume is 1/3 pi r squared times h. We're going to plug in what we know. So it's 1/3 pi times 15 squared times 20. So it's going to be 1/3. I'm going to calculate this out in parts. 15 squared is 225. times 20, which is 1/3 pi times 4,500. And 1/3 of 4,500 is 1,500. So my volume is going to be 1,500 pi, and my units were feet. 1,300 pi cubic feet is my exact answer. And my approximate answer, if I plug that into my calculator, I get 4712.4 cubic feet, rounded to the 10th. Questions on that one? Let's look at one problem where we kind of go backwards, where we solve for one of the other parts. So we have a cone. The volume equals 1,680 pi cubic centimeters, and our radius of the base is 12 centimeters. We want to find the height. So this is kind of like our opener. So we're going to plug in what we know into our formula, solve for the part we don't know. Our volume is 1/3 pi r squared h. Our volume is 1,680 pi, so I'm going to put 1,680 pi equals 1/3. What's that? Oh, 1,680. Thank you. 1/3 pi r is 12, so 12 squared times the height. $1680 pi equals 1/3 pi times 144 times the height. 144 divided by 3 is 48. So I get 1,680 pi equals 48 pi h. I just divide 144 by 3. Now I'm going to divide both sides by 48 pi. These cancel, and I get h equals, and 1,680 divided by 48 is 35, and my units are centimeters. So we plug in what we know, solve for the part that we don't know. Questions on that one? All right, homework.
Yeah. Homework. I love homework. I was quick notes there. Look at that. 30 minutes, basically.
All right, you have almost a half an hour. You can finish this and not